So good morning, everybody. Welcome to our first virtual new product launch for Beckman Coulter Southern Africa. It's really a privilege to host you today at this event. For the first time ever, we will host the new Beckman Coulter Hematology DxH 560 launch from a studio. And the studio is in Centurion, Pretoria, and South Africa. I really would like to welcome my co-host this morning, Lebogang Kupong. Lebo is our hematology product manager for Southern Africa. Lebo, I'm really looking forward to experience, engage with you, and also to review our new product and also learn together. Yes, most important today is you, our customers, our diagnostic hematology customers across the globe and also from the Southern Africa region. If you guys have comments or questions that you would like to ask us, please use the chat space. This is not live where we can interact with you and have direct contact, so please use the chat to engage with us throughout the event. I would also like to welcome our Beckman Coulter channel partners from 13 countries across our Southern Africa region. They include Botswana, Zambia, Zimbabwe, Mauritius, Malawi, Mozambique, Lesotho, Namibia, Swatini, Seychelles, Madagascar, Angola, and South Africa. We are so proud to partner with you with our diagnostic products. During the COVID pandemic, we have faced many challenges in our own personal lives and also in our work environments. We have learned about change, about flexibility, and about resilience. I'm sure if anyone asks us ourselves today, how can you chart the course for your company's success, for your laboratory's success, for your team's success, and also for your own personal success? Are you looking at today's needs and tomorrow's possibilities? You dream and you envision a future. And I want to share today with you Beckman Coulter's theme for this year. We need to chart the course in 2021 together to elevate our performance and advance patient care. So, as we said, resilience, flexibility, and this is how we change our worlds. So, Lebo, really, a DxH 560 launch live in the studio also has its challenges, but that shows that we can handle all of this. The technical guys are sorting out our video and our sound, so really just an amazing day to spend with you guys. I think we have 125 participants online. It's really amazing that we have people across the world and across our Southern Africa region that shares this day with us, with our experience, sharing our knowledge, and really making this an excellent event.
Welcome everyone. Yeah, and I'm also very excited about this launch of a DxH 560 LISO, and I'm excited that so many people have joined us today to experience this day with us. And yeah, I'm looking forward to showing you guys this new small and mighty instrument that we have as Beckman Coulter.
Yes. I think it's exciting to see that we have a new product that fit into our specific market segmentations, and we'll discuss that today. It's really a small, as you say, small and mighty instrument. It fits our small, medium to large labs, really enhancing throughput, efficiency, and really being a powerful little instrument which we really want to take some market share and show all the different features that it can bring and the value that it can bring to all our analyzers. Okay, thank you very much to the team. We can move into the next session of the launch. Okay, so Lebo, please take us through the agenda for today.
Okay, guys, so today we've got a agenda full for you guys on this presentation, being our first ever virtual launch. Liesl will take us through the first portion of our presentation today, where she'll be letting us know about how we elevate our performance and advance patient care. So Liesl is our manager in the EMA region for insights and analytics. And we will also meet the hematology team. So please, as you know, that we will not be working in silos. We have a very good team of people for hematology that have helped us to get to where we are today. And Gauri will take us through 3 parts of a presentation today, looking at the technical introduction of the 560, the principle of the 560, and the software and application of the 560. I will then take you through the demonstration, the live demonstration of our instrument, and Rachel will then later on take us through the whole hematology product overview and providing us with the value proposition. So that's what we will have for you today on the agenda, and we are looking forward to this.
Thank you very much, Lebo. So when we talk about elevating your performance and advancing patient care, I really want to talk a little bit about Beckman Coulter. So we are committed to advancing healthcare for every person by applying the power of science, technology, and our passion and creativity of our teams to enhance the diagnostic laboratory's role in improving healthcare outcomes. Our diagnostic systems are used in complex biomedical testing, and we found that in hospitals, reference laboratories, physician offices around the globe. Beckman Coulter is an operating company of the Danaher Corporation since 2011. We have more than 11,000 global associates working diligently to make the world a healthier place. We offer a unique combination of people, processes, solutions designed to help our clinical laboratories and healthcare networks elevate their performance and advancing patient care. Beckman Coulter has over 86 years of experience. Beckman has a rich history. Dr. Arnold O. Beckman has founded Beckman Instruments in 1935. It's a long time ago. In 1948, Dr. Wallace Coulter developed the Coulter principle. And we all know we're coming from hematology backgrounds, we worked in laboratories, so we are so familiar with the Coulter principle. It's almost as if it's part of us.
Yes.
And especially working for Beckman, it really makes us proud to think back to Dr. Wallace Coulter that developed the Coulter principle. Beckman Coulter has always been and will continue to really dedicate and advance our optimization of diagnostic laboratories. The Danaher Business Systems serves a very strong differentiator for Beckman Coulter today. We use the power of DBS to help us drive our core values. We have a lot of tools within DBS that we really help to optimize what we are doing, identifying where there's challenges, gaps, driving outcomes and sustainment, and in the end, help us to really drive our business to ensure continuous improvement. Common challenges in our laboratories and industries, that's what we are facing today. We all know about lab efficiency. We want to increase reliability and turnaround time, really show value, what our products can bring to the market, help you to grow and grow with you, offer the right menus, and also through that, minimize some cost and your budget constraints. Taking into account all these challenges, it's key that we position these products correctly and that we find the correct fit for our new product, the DxH 560 autoloader. Beckman Coulter is proud to be part of one of the companies whose sole focus continues to be laboratory diagnostics and performance. Our areas of strength is really aimed to advance patient care and outcomes with a menu that matters, with automation that we are bringing to our market. We have a newly launched DXA 5000. We are very proud to have that instrument. It will change the face of automation in Southern Africa. We have clinical informatics for everyone in the lab and also a focus on partnerships. That's why we have this day. That's why we have our channel partners with us. That's why we have you, our end users, with us. All about our partnerships together. Beckman Coulter's cross-discipline offers and assists us to really build lab performance. You can see that we have a variety of products and different product lines where we have clinical chemistry, blood banking, immunoassay, urine analysis, hematology, and microbiology. And Lebo, just for today, I didn't include our new product in the hematology portfolio. I think that's a big reveal that we will do later. So then, if you see the slide again, it will actually fit with our new product and how it fits into that whole portfolio. I also want to just mention our scalable automation solutions. As I said, the DXA 5000, a new instrument to the market. We are looking forward to have that place for the DXA 5000 fit and the 5000 in our markets, even before medium to large and extra large laboratories. Our benefits is scalability. You've just seen it on the slides. We can meet the needs of a small lab, medium, large, extra large labs. And we do that scalability through three things: meeting turnaround time, having efficient labor utilization, and also lowering our operating costs.
Okay, so for this launch today, as I've indicated, Lizelle and myself are not the only people that have behind this launch. We have associates and leaders that are coming from a diverse array of backgrounds and experiences that will be sharing this day with, and we all share one thing in common. We share our commitment to moving healthcare forward for the laboratories, the clinicians, and their patient. So here, our team, even the teams that are behind the scenes today, you will see Liesel, myself, Yokohang as a product manager, Gauri as the marketing manager for the EMA, and Rachel as a marketing manager also for the EMA, Bart as a technical support manager, Mark is a senior engineer, and Lizelle is our hematology. So thank you guys for being here with us today and helping us to bring the small and mighty DxH 560.
And on the website, if you guys go to the link, there's full bios of our presenters, and we would really like to thank them for their time and their commitment today. We know Rachel as well is in the US, and we appreciate the early wake that you are with us today and that you are sharing this special day with us. We will move into our first part of our presentations. Gauri, are you online?
Yes, hi, good morning.
Good morning,
Good
Gauri.
morning, Gauri.
Hope you can hear me and see me.
Yes, we can. We
Yes,
can.
we can hear you.
Good.
Welcome.
So please take us through your presentation, Gauri. You can just let me know when to change the slides.
Perfect. Thank you, Lizel. So good morning to all the participants, and thanks for making time for this event. So this session actually is to go over our newest DxH 560 autoloader system. As we all know, that the business side of lab operation can be increasingly demanding with data management needs, cybersecurity guidelines, further complicated with the balancing of budgets and full-time employees' involvement in running the lab operation, and all of this without compromising the quality. In this presentation, we will look at feature sets in a modern hematology analyzer, like the software, the user interface, management of patient and QC data storage, archival of the data interface to the laboratory information system, and how the DxH 560 autoloader system enable you to overcome the above challenges while still ensuring quality of results and utilizing a proprietary cell analysis technology. Next, please. So, as Lebo introduced earlier, this presentation is divided in 3 sections. And next one, please. So in the first session, we will look into the product itself, the overview of the key attributes, and some of the system performance specification. Next, please. So the DxH 560 is a product that is designed with the user in mind. So it will meet your time, resource, and space needs. Some of the attributes that you see on this slide is, first of all, it takes only 50 centimeter on the bench space, utilize only 2 reagent and 1 cleaner. The autoloader allows you to load up to 50 tubes and walk away. So give you a freedom of nearly 1 hour of operation, which is hands-free. You can continuously add more samples as you progress. The instrument does not have any requirement for daily user maintenance. It's only 1 startup or daily check, and we recommend 1 shutdown every 24 hours. So the software on this instrument is allowing the lab to connect through a bidirectional laboratory information system interface to work seamlessly within the operation of the lab. The user will interact through a touch screen, a high resolution color touch screen, and of the size of a tablet, small tablet. And none of the features in the software are more than 3 clicks away. So very quick and efficient way to interact with the instrument. The requirement of blood is also a key area in this segment of the market. So the instrument only needs 17 microliter of whole blood to perform CBC and diff. And in addition to all the IT capability, it has its own storage space for 30,000 patient results with all demographics and information. So in places where the connectivity with the LIS is not there, it has its own huge database to manage. And the analysis is done utilizing the advanced flow cytometric method of counting and sizing. Next slide, please. So this is the front and the rear look of the instrument. You can see it from different sides. Everything that you need to run the instrument comes with the instrument, like a handle barcode reader and so on. So although it is designed to be paperless, but you can also connect an optional printer and print your result directly from the instrument if so desired. Next. So we talk about the utilization of the counter space in the lab. So compared to its nearest competitive instrument, it has 1/3 smaller footprint. And if you see the dotted line, that is the area that you need to place one of the nearest competitive instrument on the bench. So it's only 50 centimeter wide and 40 centimeter in height and about 46 centimeter in depth. Everything is integrated into the system. You know, there is a touch keyboard, touch screen software, and only one reagent external. Next, please. Yeah, next slide, please. So in order to have an efficient workflow, you want to have a system that does not require frequent reagent changes or priming and so on. So it uses a diluent, a lyse, and a cleaner. The cleaner and the lyse are stored on board, and they are sufficient to manage the workload of a low volume to lower end of the mid-volume laboratory. So you can do hundreds of cycles from these reagents. Then, as I mentioned earlier, there is no routine maintenance requirement. So there is zero hands-on daily cleaning that is required. So if I'm using the system, I can perform a shutdown at the end of the shift, or I can choose a time of the day when it is quiet in the lab. At the same time, I can ask the system to come out of the cleaning cycle, perform a daily check or a startup, and be ready. So, you know, like before I come to the lab next morning, the instrument could be up and running and waiting for me. Next slide, please. So with the launch of the DxH 560, for which we are very excited, we actually complete our product portfolio for the low volume laboratories. And we have a very successful DxH 500 launch a few years ago, and then we launched the CAPIERS version or closed tube version, the DxH 520. The 560 autoloader is actually built on the reliability and performance that we have, and a lot of the things that we have incorporated into the system is based on the user input that we collected during our previous instrument release. So capacity to load 50 samples and walk away, and you can add more samples as you needed. The instrument can process up to 55 samples per hour. And if you have a blood sample that could not be run in a closed while, or if you have an urgent stat sample, it also offers you to run a sample in the open while mode. Or if you have pediatric samples in a microtrainer, they can be run in that mode. And the speed is 60 samples per hour in that mode. So as you see on the image here on third, number 3, you load your cassette with the tubes, and you can stack them up. The instrument will take the cassette in, as you see in figure 5, and what it will do 20 inversions to thoroughly mix the sample, and then it will run the first sample. While it is running the first sample, the cassette will go to the mixing cycle once again. So it's continuous mixing. Next slide, please. The analysis system for autoloader design has to take into account the variety of tubes that are used across the globe in the lab. So the system will accept tubes with a diameter of 11 to 13 millimeter and the length from 65
with
to,
a spark,
to 75 millimeter.
which fueled the fire, igniting wind.
In the standard cassette that comes with the instrument, and you could actually put in different type of tubes in the same cassette, and it will process them. Next slide, please. So for the user, we provide a monograph in which you have list of different type of tubes that can be utilized on the system, and some basic instructions on managing the tubes. Next one, please. So by designing a system which takes only 17 microliter of blood, allows you to run samples from difficult draws, pediatric sample from elderly patient, or where it is difficult to draw blood, then it's just the right instrument for your choice. And when you do not have enough blood to meet the phlebotomy requirement of the type of tubes that you are using, you can always run sample in a open tube mode from different shapes and sizes of microtrainers. Next slide, please. So the capability of the instrument designed around the low sample volume requirement really help to run samples from the pediatric population and report result with full confidence. So we worked with Caliper in Canada and established the reference ranges for pediatric population, and those are referenced inside our IFU, where you can see the ranges that we established. So next slide, please. And this is the publication that is out there on our website. Plus, you can get access to this through the link in here. So really geared towards meeting your need for these special microsample requirement. Next one, please. So this slide actually covers various aspects of the instrument specification. It may not be easy to read for all the viewers, but I put it in there so that if you have any specific question, I could come back to this slide. So basically, what is there is the mode of operation, the sample volume, the throughput, and the parameters that it actually reports. And in the presentation, in later section, we will talk about the QC package, the user interface, the power requirements. So it works from a standard 220 to 40 volt outlet. The power supply is an auto volt power supply. It's like you have for a laptop, but this is medical industry grade power supply external to the instrument. So anything from 100 volt to 240 volt, you don't have to worry about settings or anything. It will run from the mains, and it consumes less than 120 watt of power. And it operates in a standard laboratory environment without any special needs. So the size of the instrument and low power requirement makes it an ideal instrument for not only fixed installation, but also installations on mobile vans or taking the instrument to remote locations and operate from different situations. So the user will have the full access to the 30,000 patient results that are stored, even when they are not connected to a laboratory information system. Next slide, please. I think at this point in time, we will pause and we will take if you have any question on the section that we have covered so far.
Thank you very much, Gauri. Really very interesting with a lot of technical specifications, and that's what we wanted to know, that it's a smart, small, compact little analyzer. We have two questions. One from Bart Broodryk this morning. Does the DxH 560 autoloader have the ability to perform an auto shutdown?
The instrument allows you to shut down the instrument at time of your choice. And when you do the shutdown, you can tell the software how long to stay in the cleaning reagent. After the time has elapsed, you could either power off the instrument, or you can ask the system to do a daily check or a startup. So it will perform the startup routine and be ready. So a scenario, for example, I'm working in a single shift clinic or a lab, and at 4 or 5 o'clock, it's time to go home. So as I'm leaving, I can initiate the shutdown cycle, and I don't have to be there anymore. The system will shut down, stay in the cleaning reagent, and then based on my decision of powering down or starting up in the morning. So for example, I can say 6 in the morning, you start up, do the daily check. So when I come back to the lab at 7, 7:30 or 8 o'clock, the instrument is up and running and ready for me. And that is the convenience that we have built into the software.
Thank you much for that.
Thank you, Gauri. The second question that we have, are the patient demographics pulled through from the LIS?
So the bidirectional interface allows you to take the patient test request along with demographics into the system. So they become part of the work list of the analyzer. When you run the sample, which will have a barcode label, or you will enter the ID manually, then it will match that sample ID with the preloaded requirements of the test that you already have from the LIS. And then the two things will match, and your result will be available in the instrument database, as well as it will be transmitted to the LIS.
Thank you very much. We also know that the DxH 560 has very little power usage, and I think that's one of the things that we know, especially in Southern Africa, that we really require that feature, and that we know that, yes, it doesn't require a lot of power, really very powerful. So Gauri, let's move into the next section. I'm sure guys will give us more questions online. Please use the chat option and then we can move into the next section. Thank you very much.
Okay, thank you. So next slide, please. So in this segment of the presentation, we will actually be covering the technology that is applied in the DxH 560. We will highlight the WBC diff, the RBC analysis, and how the platelet measurement is performed. And we will see some of the proprietary algorithm and the gating strategies that we have applied. So next slide, please. And next one. So the foundation of this instrument is based on utilizing two distinct methodology. One is measuring the cell volume utilizing the advanced digital Coulter principle, which is also referred to in the industry as the impedance method, because that is the method of accurately measuring the cell volume. Not size, but the cell volume, because cells are irregular in shape. So measuring them by diameter is not the true measurement of the cell, but the volume of the cell with the Coulter principle gives you the true understanding of the cell size. So as each cell passes through an aperture in which you have a current flowing, the direct current, and this cell will act as an insulator, and it will momentarily increase the resistance of the electrical path between the two electrodes. So with the passage of this, the change in resistance will be converted into a pulse, and the height of the pulse, as you see in the diagram, is going to be proportional to the cell volume. Next slide, please. So here you can see in figure A the schematic of the Coulter principle. In B, you see, graphically that how cells, enters into the aperture. And when the cell is right in the middle of the aperture, as you see in the figure D, a pulse is produced, and the height of this pulse is proportional to the volume of the cell. All of that happens in a tiny aperture sensing system that you have in the figure C here. Next slide, please. So one of the things that makes this different to a conventional flow cytometer is that we perform the electrical sensing of the cell volume by the digital Coulter principle, while we take optical measurement by the flow cytometer on each cell. These two things happen simultaneously. In order to ensure that the cells that is being measured is passing through the most sensitive area of the aperture, which is through the middle of the aperture and not coming in from a very acute angle. So here you see examples of a perfect bell shape or Gaussian curve produced, represented by the figure on the left as T1. If the cell comes slightly off center, you would see the blue pulse, or if it comes further off center, you see the pulse T3 in the green dashed line. Only when a cell enters in the system at a very awkward angle from the corner, the pulse represented here as T4, what we do is that we reject that measurement, because this is not a true measurement of the cell volume, and this cell will not be utilized for optical measurement. So by utilizing this digital pulse processing, we eliminate the need for having a complex sheath flow mechanism that is often utilized in the flow cytometer to make the cell flow from the middle of the aperture. And that results in a system which is small, simple, and highly reliable. Next slide, please. So on the dot plot here, right-hand side of the image, you see cell volume being plotted on the y-axis, and the optical measurement, which is referred here as axial light loss, or ALL, is plotted on the x-axis. The green that you see here are the monocytes. Blue is the lymphocyte population. Number 3 in purple is the neutrophil population. Number 4 in orange is the eosinophil population. And the basophils are right in the middle of lymphocyte, monocyte, and neutrophil, represented as number 5 with the white dots in the middle. So lymphocytes being the smallest in volume and also having a small nucleus, they don't really make much scatter light. So they are in the bottom left of the dot plot. Monocytes, being the larger cells, are above the lymphocytes, and neutrophil, you see the spread on the x-axis on the neutrophil population because they have a varying degree of internal structure. The shape of the nucleus and the granular component, makes this cluster much wider on the x-axis. Some of them could be as small as lymphocytes, and some will be as large as monocyte. Eosinophil, having their characteristic orangey granular structure, will make a bigger impression on the axial light loss measurement, and they appear further to the right of this population. So the 5 common type of white blood cells are simultaneously measured and recognized by the instrument software using a single lysing reagent. In the next slide, you see in figure A here is the counting and sizing system, the inner working of the instrument. So this is the WBC bath on the right hand side where the first dilution is made, and from that we make RBC dilution on the left hand side bar. Then the lyse is added, and what this lyse is going to do is going to gently lyse the red blood cells. So before we go to the count cycle, the red cells are all but eliminated. Hemoglobin is released as a oxyhemoglobin color pigment, which we measure optically. Though the system utilizes one aperture for WBC and one for RBC and platelet, but because we do 2 sequences of counting and sizing, so in the first 3 seconds, while the sample is still being stabilized for differential analysis, we are counting the white blood cell, red blood cells, and the platelet. And then the second count period starts, which lasts for 7 seconds, as shown here, where not only we do the CBC parameter counting, we also do the differential. And software applies an internal algorithm to check the flow rate and see if the count is free from any interferences. It can apply a voting mechanism. So we ensure that when you get a result, it is coming from a reliable dilution, sample preparation, and a very stable monitoring and measurement of cells. Next slide, please. This is a snapshot of an animation that you will be seeing in a later part of this presentation, showing you the inner working of the optical measurement. So as you see in figure A, that's the tiny flow cytometer arrangement. In B, you can see that the cells are passing through, and as they are passing through the aperture, we are measuring their volume. And right in the center, they will interrupt this blue LED light. And then if you see in figure C, From each cell, a volume pulse is produced and an optical pulse is produced. So different cell types, due to their granular structure and cell volume, will produce pulse of different proportion. And at the end, we will have all of these cells measured and counted. Next slide, please. So in here, you can see the pulse height and shape of different type of white blood cells that result into the formulation of this 5-part differential scatter plot. Next slide, please. So conventionally, instrument of this size and this segment use fixed gating, but we utilize our technology from our high-end instrument where we apply a dynamic gating algorithm. So at the end of the count, these gates, as you see, are adjusting to find the best separation between different cell cluster. Applying this technology that we call dynamic gating, we were able to reduce the review rates from a fixed gate algorithm that was initially launched back in the days with the DxH 500 by up to as much as 40%. So you have a system that is responding to the cell population in the patient blood and drawing these clusters separation in the best way possible. And even after that, if there are some overlapping population, the instrument will produce a flag to direct the user towards a possible overlap, let's say between lymphocyte or neutrophil or monocyte and neutrophil and so on. Next slide, please. So within the instrument, we apply this algorithm to ensure that when a result is produced without any flagging, it is available to report as early as possible, and the sample that you review are really those which require further investigation because of the abnormality of the sample or the cell types that are present in the sample. Next slide, please. The color as I described and the position of these clusters are very similar to what you get from our high volume instrument like the DxH 900 or DxH 800 or 600, 690T in this arena. So it's very easy for the user to move from one type of instrument to the other, especially in a hub and spoke setting, or in a lab where you apply different instrumentation from our system. The familiarity with the software and the gating and positioning of these cells, will make technologists feel at home. Next slide, please. So when there are cell populations which may not be nicely separated with the gating strategy, then the instrument will flag, as shown in this table, different overlapping population to draw attention to the user. Next slide, please. As far as the platelet analysis is concerned, the system utilized the same counting and sizing aperture for the RBC. And that histogram that you see on the left-hand side is monitored for several different areas of the histogram plot. In here, we want to see any interference at the lower end. We want to make sure that the platelet distribution curve is positive. And then, if there are any very large platelets present, so the section that you see here, 3 and 4, is utilized to monitor that. Number 5 on the left-hand figure is the area which is a floating threshold, and this is to ensure that, if there are microcytic red cells present, we can position this threshold in such a way that we can, report platelet without any interference from the platelet. On the right-hand side of the slide, you see a platelet histogram with various messages. So we generate platelet flag, platelet 1, 2, which are normally related to the debris or interference on the lower end, or platelet 3 flag only when there is a suspect overlap between microcytic red cells or the platelet population. So the user is alerted for those scenarios. Next slide, please. Histograms for RBC and the platelet histogram are part of every sample result. And here you see typical normal histograms with their characteristics. And they are covered very nicely in the instrument IFU for interpretation and understanding of the flags. Next slide, please. For hemoglobin measurement, which is performed in the same WBC counting bath, so the lysing reagent converts the hemoglobin into a stable oxyhemoglobin, and it is measured by a green LED at around 545 nanometer wavelength. For every sample, we take a blank reading, and it is the difference between the blank and the absorbance or the light transmittance that is measured, which is converted into the mass of the hemoglobin and reported in selection of your units. So in this example, gram per deciliter or gram per liter. Next slide, please. So that brings us to the end of the second part, and very quickly I have tried to highlight some of the technological features and advances that we have in this instrument. And now I'm happy to take some questions from you. Thank you.
Thank you very much, Gauri. Really a powerful principle that we have on our instrument. We were discussing it now in the studio as well, Lebu.
Yes, thank you very much, Gauri, and talking us through our heritage of the Coulter principle and how the instrument works. The question that we have here is that does the DxH 560 use the same principle as the other small hematology instruments, the DxH 500 and 520s?
Yeah. So thank you for the question. The 500 family utilizes all of the same technological advances that we have in this family. So technically, they are using the same technology. The difference is only being that the 500 only runs samples in an open vial mode. The 520 will run open vial and closed tube mode. The 560 is the autoloader version of the 520. Having said that, the instrument, if you today acquire the DxH 500, is not the same instrument that was launched in 2015. Mm-hmm. So this dynamic gating was introduced with the 520, but we upgraded all of our 500 series instrument with the launch of this algorithm. So several advances that have taken place have all been retrofitted to the existing system. So today, the 500, 520, 560 will have the same technological feature built into them.
Thank you, Gauri, for clarifying the question. Any more questions, Lisa?
Yeah, Mark also asked the question, Gauri, does the DxH 560 ensure that lyse and the blood is mixed correctly in both our red blood cell and our white blood cell chambers? So maybe a little bit of a technical question, but also addressing some of the principles we use.
No, it is important. So we need to lyse red blood cells for two reasons. One, to count the white blood cells and do the differential, and second, to measure hemoglobin. So the lyse is only added into the WBC counting bath. When we are measuring the red blood cell, there we don't need to use any lysing solution because you have about one white blood cell for every 1,000 red cells in a normal proportion. So the number of white cells which are present in the RBC bath are statistically insignificant. So they are ignored. So for example, if you have 10,000 white blood cell in a patient blood, this will be 0.001 in the RBC counting, which is in millions. So you don't have to apply any lysing reagent in the RBC bath if that was the question.
Thank you very much. I think we can move into the section 3. Looking forward to listen and learn a little bit more about our application of the DxH 560 and what it can do for us in our laboratories.
Thank you. So as Little mentioned, in this section, we will actually look at the overview of the instrument software, the user interface, and how it relates to the application of this instrument. So really, the key areas of our design for the performance for the lab is that how we can design a system which actually can reduce the manual reviews of the slide when reporting the 5-part differential and counting red cells and the platelet. The other thing that was top of the mind was managing patient results. So it's okay to have a big data storage, but what is the use of this? So when you have 30,000 patient results with all the demographics and histograms and dot plot, you want to have a system which allows you to easily retrieve those results. And having a large database gives you the capability to perform, check on a patient. If somebody is inpatient, you can look at records, spreading over weeks and months, apply delta check and so on. And having a database with the capability to archiving gives the laboratory the power when there is no LIS to actually have an operation in the lab with a system that allow you to maintain a digital record of patient sample results. This database is also very effective in case if the LIS system goes down for some reason. You could continue to run your operation, and once the LIS comes back online again, you can transfer your patient results. Having patient information on the system also puts some security requirement onto an operating software. So we include, security in terms of operation of the instrument, in terms of encryption of the patient health information, and also when system is not in use, it can automatically log out of the software, so nobody can have an unauthorized entry into the system. So later on, we will learn how different systems can be applied in the software. Next slide, please. So the data management tools that I just described allows your laboratory to focusing on providing the patients with the most valuable resource in the lab. That is the time. So let you do things more effectively and more efficiently with minimum interaction with the instrument. So the instrument is the one who should work for you, not you work for the instrument. So next slide, please. So this is a snapshot of the patient result screen. as you can see on the left-hand side of the screenshot, you have the icons for the most common functions: database, work list, daily checks, QC, and logs and setup. And these icons are accessible from anywhere in the software. All of the patient result numerically, the demographics, and the dot plots are visible on the same screen. Plus, you can scroll through patient records by using this forward and rewind button and so on. So things like logging out or printing the results on the right top of this screen are quickly accessible. And in the dialog box right in the middle top, it tells you where you are in the softwares. There is always navigational help at your fingertips, so you don't always know where you are. Next slide, please. So touch screen software, and anywhere in the software you can go with no more than 3 touches. So for example, if you want to look at the diff scatter plot or any of the histogram, by touching on it, you can make an enlarger view. And I show this on the next slide. So you can have an enlarged view of the diff population, especially useful when you have abnormal cells or flag in the patient result. Next one, please. You can enlarge RBC histogram and platelet histogram the same way. Next slide, please. So a QC management package that is built into the software, it has features that are borrowed from a high volume instrument. So if you are a user of our large DxH instrument, you will find yourself at home because it has all of those features, starting with 12 control files, and each file can have 150 data points. You have ability to perform not only the standard QC practice, X bar B, XM, but you can also extend this QC package in the XM profile. Levi-Jennings plots, you can see a shorter or a mini view of the plot. By clicking on the plot, you can make a larger view and see entire data for the time that you are looking at. And the QC package also allows you to take part into the intra-laboratory quality assurance program that we offer. And this is an online IQAP program which allows you to upload all the control results into a USB memory and then upload to our IQAP site. And then you will have a peer review from those users who are using the same instrument and running the same QC. It is based on the usage of the quality control that you run on the system. Next slide, please. So to establish a good working instrument, you rely on running commercial controls. So we have a dedicated control for the DxH 500 family. And this control comes with a package insert, which is having a 2D barcode on it. So it's just one scan of the barcode and all the values for your 3 levels of control are in the system. It comes with the open vial stability of 14 days. So you have 2 vials of low, 2 of normal, and 2 of high control in it. Same way, you have a calibrator. So when a calibration has to be performed based on your laboratory protocol, the calibrator will also have an assay sheet with the 2D barcode label. So it is designed to be really as efficient and quick to incorporate into your QC mechanism. The software perform all the QC data management and gives you the reports that I showed in the previous screen. They can be printed, plotted, transferred to LIS, and also archived as per your need. Calibration is also being done as a fully automatic cycle. The reagent management system on the DxH 560 has full visual capability, so you can go into the reagent management screen and you can see when was the reagent stored, how many cycles are remaining, when is the expiry, and what is the open pack expiry. It also allows you to prime when you change the reagent and so on. So one area in the software totally dedicated to the reagent management. All of our reagents are having a barcode printed on the vial, and with the included scanner, you can scan the barcode of the reagent, and it is fully traceable, and then eliminating the chances of any manual entry. Next slide, please. In our effort to go paperless, the bidirectional interface for patient data management and also QC plays an important role. Here you see a part of the back of the instrument where you can see various connections. So there is one USB in the front, 4 USB connections in the back. You have an LIS connection using the RJ45 Ethernet port, plus it is possible to connect the instrument through a serial 9-pin RS232 port as well. So adaptable to various type of networking environment in a lab. Next slide, please. So the access to the instrument software is designed in such a way that you can assign user access as an standard operator or as a supervisor or quality control manager. So you can restrict the areas of the software which should only be managed by a team leader or supervisor in the lab. And that way, you know, you maintain the quality and areas, you know, where there is flagging, reporting type, and the sensitive area of the software can only be open to the people who are having responsibility in the lab. If you leave instrument unattended, you know, it will lock the screen by itself. And like any modern software, you have full control on user access, expiry of the password, and the roles and responsibility in the lab. Accordingly, it can be assigned. So really easy user interface and easy to manage. Next slide, please. All of these will only be good, you know, if the instrument is dependable and reliable, and it can produce results as good as on Monday, as on Wednesday, day after day, and month after month. So with a huge install base of this DxH 500 family, the instrument that we have, you know, we continue to maintain a very good track record of reliability. So the 560 is built on that proven reliability record, where our design aim was not to have more than one service call in a year for this segment of the market. So we constantly track our service records and make sure that if there is a problem, it is tracked and we bring a solution to that problem. So the 560 autoloader help propel your productivity and really designed to meet your time, resource, and space needs. With that, I would like to pause again and see if you have any question. Next slide, please.
Much, Gary, for talking us through the software of the DxH 560 and the applications thereof. The question that I have here from Bar is, can we indicate if the count vacuum for counting the cells are monitored on the system to ensure consistency and repeatability?
Yeah, so thanks for the question. to have a system as reliable and dependable as we just saw, it wouldn't be possible without having many checks and balances to monitor the key component of the performance criteria. And as the question is about the count vacuum, which is the key part of doing a stable and reliable count, so instrument perform these checks during the operation of the instrument. So, just before going into the count, it checks that all the counting parameters are within the specified limits. We do it in a small system like this one, and we do it on our largest ophthalmology instrument. So all of these things are behind the scene. Service engineers, they have access to this information by a special login, and the user is alerted if any of these key telemetry information is outside the specification. So they get an alert message. Every event is recorded in the software. So there are logs about reagents, controls, calibrator, QC, patient, and logs also about any event that might happen during the course of the operation of the instrument. So it is fully traceable, trackable, and the instrument operator manual provide you a hyperlinked help. So you don't have to really read pages and pages to get to the bottom of the problem. In the troubleshooting section in the manual is all hyperlinked. Yeah.
I think, thanks for that, Gauri. I think something that comes up in every laboratory and a question that we will always get is, what happens when the database is full? How do we handle that? It's a practical question from the labs. So can you elaborate a little bit on that?
So could you repeat question? What happens if
What
the
happens if the database becomes full? We are saying we can save 30,000 samples and information. What happens when it becomes full?
Okay. So the database is designed to be first in, first out. So imagine 30,000 patient results for a segment of lab in which this instrument will be used, will be good for months and months of data. User will be alerted, and you can archive from the front USB all of these patient records. And you can program your archival routine based on your laboratory workload. You can delete the records in the database to make room for the new one. But because it is first in, first out, the oldest patient records will be deleted to make room for the new one. So even if I decide not to do anything with the database, it is keeping the last 30,000 results in the system.
Thank you, Gauri. And I think that it is good laboratory practice to continuously back up the data, patient data in the system. Yeah.
So not only that, the software of this instrument allows you to make a backup, you can also archive. So for example, if there is a problem in the system which will require to change some electronic circuitry, the service engineer will advise that make a backup of your data, and you can archive on the USB, fix the problem, and after that you can restore the entire database on the system.
Well, thank you very much for that, Gauri. Another question here from Mark says that does the 30,000 include daily checks and QCs, or does the database only include patient results?
Yeah, so the figure 30,000 is relating to the patient records. So we have 15 files 150 data point each for controls. That means you can maintain 4 months of QC online, and then you can archive or delete and make room for the new control files. Same way, all of the logs, they have a capacity. So for example, I think it is 300 records for the daily checks that are maintained on the screen, and it is first in, first out. So all of these critical components of the electronic record keeping are managed separate to the patient database. And at the time of installation and training, our application team will train the user on the use of these critical components, as well as you will have full information in the IFU about the storage capacity for various sections. So no, everything is independent. Your QC records, your work list entries, your events log, separate memory. Yeah.
Thank you.
Thanks,
Thank you very
Gauri. Also a practical question from Thomas. What is the frequency of preventative maintenance on the DxH 560?
Okay, thanks for the question. So on a daily basis, there is no maintenance requirement as such. Our recommendation is to perform one shutdown with the onboard cleaner for every 24 hours, and it has to be done for minimum of 30 minutes. And every time you do a shutdown, it has to follow by a daily check. Periodically, there are some maintenance sequences, and they are linked with the number of cycles or patient runs that you perform. So there is a table in the IFU which takes you through those steps. So this is not an instrument that require heavy maintenance from the user part as such. There will be one preventative maintenance that will be done by our service team in a year, and all the consumables that are required in a preventative service, like lubrication grease for the syringes and some O-rings, they come with the instrument. So there is a cleaning cycle which is performed automatically in addition to the shutdown to make sure that there is no protein buildup on the counting aperture, and that is programmable by the user, and it works behind the scene. Then, depending on the daily workload, there is a bleaching cycle that has to be performed. For some lab, it could happen bi-weekly or once in a month, so it's not something that is heavy on the maintenance. Yeah.
Thank you very
Gauri.
much for that. Let's move into the next section of our schedule and our agenda. Gauri, thank you very much for all your knowledge that you are sharing with us. We really appreciate all your support and your valuable time. We are proud to have you as part of this hematology team.
Yes, thank you very much, Gauri.
Pleasure is all mine. Thank you so much for having me for this event. Thank you.
Thank you, and I think Gauri will stay online. If you guys have any other questions, please post them in the chat. Our team will help to answer them. Gauri can answer them as well, so that we can have engaged discussions on the chat as well. I want to share with you that Beckman Coulter is proud to be part of Danaher, and with that, we are helping to realize life's potential every single day.
For 30 years, we have lived a shared but quiet purpose. It started as an idea for a better way, but like all powerful ideas, it evolved into a passion. It's not something we've written down. It's not something we've posted on a sign, but it has guided our journey from the beginning. Our shared purpose is in everything we are and everything we do. It's what gets us out of bed in the morning. It's why we view every challenge as an opportunity. And it's the reason we're on a constant quest to make things better for ourselves, our customers, our company, and the world. A purpose bonds us together. It aligns us all to what we must do every day to achieve our most ambitious goals. It has its foundation in our 5 core values and is operationalized through DBS. For our associates, it's an opportunity to make a meaningful contribution to something larger than ourselves. For our customers and the world, our purpose confirms our commitment to helping them achieve amazing things and the high standards by which we measure success. We are their agents of possibility. Our shared purpose, helping realize life's potential. It's what has made us who we are today, and it's what will guide us into the future. We help our associates, customers, and businesses achieve their goals. We innovate meaningful technologies to solve our customers' most critical challenges. We unlock the amazing potential of our associates. Helping realize life's potential isn't just a work mantra. It's not a backpack we hang up on Friday and sling back on Monday morning. It permeates everything we do. It's who we are. For us, it's the greatest reason for being. The impact of our shared purpose goes beyond business. It's about our journey to improve ourselves and the quality of life around the world. We are a diverse family of people and operating companies, each with our own goals, strategies, and missions. Yet we are bound together by our shared purpose, which makes us an unstoppable force. Helping realize life's potential. It seems simple, but like a lot of truths, it only has impact if it's embraced. Believe it, live it, lead by example. It's how we have and will continue to make a difference in the world.
Well, thank you. That was the most exciting reveal of the DxH 560. And today I'll be demonstrating for you our small and mighty analyzer here that we have today. So I've set up 2 instruments here today so that I'll be able to fully demonstrate all the features of the instrument. Are we able to hear me? Great. Okay, so the DxH 560 autoloader is a very compact powerhouse hematology analyzer that combines many of the analytical strengths and data management capabilities of a high volume instrument with an ease of use of a tabletop system for the low to mid volume laboratories. As you can see here, the DxH 560 fits very nicely on a tabletop and has 50 centimeter wide in width, 46 centimeter in depth, and 44 centimeter height, and weighs only 22 kilograms. From the front view, we can see the screen, which is a touch screen, the power button, as well as a LED indicator. Here we have the input area of the instrument, where the sample will be moving from the left-hand side to the right-hand side to the output area. Here we've got the front USB port for easy access during uploading or restoring of the data. On this left side view is the reagent compartment. This is where the two reagents will be stored, the DxH 500 lyse and cleaner. The DxH 560, as Gary has indicated in the presentation, uses 3 reagents. So this 2 stays inside the compartment, as you can see, and the diluent is on the bench. Okay, the backside view, we've got 4 more USB ports available. These we can use to plug the USB printer, as you can see demonstrated here, and we can also plug in our barcode scanner. The instrument that is able to connect to LIS bidirectional, we have a option to connect to LIS. We've got the waste and diluent connectors here at the back. Okay. So this is giving you a 360 view of the instrument. Here is an output area where the racks will be unloading after they have been processed. And as you can see here, we've got the a sensor for when the racks are full onto the rack. Okay, so on this right side view is the diluter door. Okay, with this tool that is part of the maintenance kit, you are able to easily access this compartment of the instrument for as needed maintenance. Here you can easily clearly see the 2 bars that was indicated in the presentation, and here is the sample probe, and the flow cell is at the bottom here. Okay, so very easy to open and very easy to close. So you don't have to be a technical engineer for you to be able to open the system. Right, so that will be the 360 view of the DxH 560. Now, this small and mighty analyzer was designed to meet your laboratory needs. This is to deliver high-quality results, increase efficiency, and maximize productivity while reducing overall cost. So now this compact size instrument, the small footprint, 5-part diff autoloader is exactly what your lab will need if you have any limitations on space. Okay. Now, the DxH 560 comes with 10 racks. As indicated in the presentation, we are able to load 50 samples with a load and walk-away capability. So the racks that are available when the instrument is delivered are these type 1 racks. And as indicated, we are able to load multiple types of tubes, and the tube list is available. Okay, so now the type here, we can see the arrows are facing down to indicate the direction that the cassette should be facing, and the arrow moving forward shows that the direction that the cassette will move into the instrument. Each cassette has got a number, so this cassette is number 3, and this cassette, as you can see, is number 6. Each cassette can load only 5 samples and has got positions from 1 to 5. When loading the samples onto the rack, please ensure that the barcode is facing outward so that the barcode reader in the instrument is able to read the barcodes. You easily slide in the tube as indicated here, and the barcodes need to be facing correctly. If the barcode is not facing outward properly, the instrument will not be able to read that barcode, and it will then skip that and provide a automatic or sequential sample ID to that sample. Okay, so for my first demonstration, okay, please, so I'll be logging into the system. Okay, so for the purpose of this demonstration, I'll be logging on as service so that I am able to demonstrate all the features that I need to be demonstrating to you today. Okay, so this 8-inch screen has got all the main icons on the left-hand side. This is a very intuitive, very colorful touchscreen and easy to use software, and you are able to perform any task with 3 or even less touches. Okay, so for me to demonstrate to you how we process a sample, we will press here on a display or run. You can see a little tube with a running man on it. Okay, so I will take my samples out. Okay, I have going to load my samples. Unfortunately for this demonstration, I do not have any barcodes. Okay, so it's as easy as that. To remove a sample from the rack, you just push it and then it will protrude out. So as I've indicated that the autoloader can house 10 racks, 50 samples at a walk-away capability with a throughput of 55 samples an hour. So I will now put in my rack, making sure that the arrow is facing down and the other arrow is facing towards the direction that the sample will be going. All I need to do is press start. The warning will say, okay, daily check. Okay, because my instrument was switched off. Okay. All right, so I will not be able to perform my run before I do my daily check. Okay. So for me to perform a daily check, we have to go on the main icon. We press on daily check. Okay, so here on this button, there's a daily check. You have requested for a daily check, so I will be able to continue. Okay, so as Gary has indicated that this instrument, you are able to pre-record this step that I'm doing here now if you want the instrument to be ready the minute that you step into the lab. So you can pre-program when the shutdown and startup should happen, and this daily check that I'm currently running will run thereafter, and it will do the background checks and all the system statuses. Okay. So currently now the instrument will run this daily check. It will not take too long. It's about 6 minutes for the daily check to be completed. So this will happen if you have not already pre-programmed this task to happen. This is the only daily check that you have to do on the DxH 560. Okay, so I'm not sure if there is any questions so far on the chat. Please, guys, ask questions. And if there's anything that was mentioned on the presentation that you would want demonstrated today, please feel free to put those questions on the chat, and we'll be able to demonstrate for you those tasks. Okay, so now let me just go take you through the menu menu icons on the side here on the left hand side. So on the top we've got the back button. This will allow you to go out of an action that you have done if you want to go out of that. Then we've got the display and run. This is what we'll be using to process the samples as well as to run our QC. Okay. And then on patient result is where we are able to check any previous results that we have processed on here. We are able to also reprint or transmit those results. And if you are a person that would like to work with work lists, this is where you can set up your work list. And this daily check is where I am currently, where I'm running my daily check of the instrument. This is basically looking at the background checks. Obviously, the diluent, because it's the main reagent that is used, we need to ensure that there is no contamination onto this diluent. So it will be running the parameters white cell, red cells, hemoglobin and platelet. It will also give us the status of the instrument, which is the vacuum that was asked in the questions, and the temperature, syringes, the probes, and all the probe mechanisms. So in this sense, it will be giving us all the system checks to ensure that the instrument is working. And here it will give us the status of the reagents that are on board. The next icon is for QC and QA. This is what we will use to check our controls. Supplies is where the reagents are monitored, as well as where we will be able to change our reagents. And as Gary has indicated, this system has got many logs, so you are able to go through every logs for reagents, logs for daily management, log for QCs, and all the other logs for the traceability point of view. On setup, this is where we are able to set up anything on this instrument, from the date to the time, to the printers, to the LIS, and everything that you will need to set up on the instrument, you are able to do that here. Okay, so this buttons here on the diagnostics, as you can see, it's got a little tool there. This is what we will be using to do the as needed maintenances that was being discussed earlier on. So for example, the bleaching of the instrument, and also any other troubleshooting as needed as prescribed with the cycles. On here we've got functions. This is where button that we will use for us to transmit or retransmit or reprint our results. Okay, so it looks like our daily check has come to an end, and as you can see, the status of my instrument is all passed, so it's good to go. And also I have enough reagents in the system, so everything is all green on the reagent status and cycle. So we're just now waiting to see the background results. Okay, so the LED light has gone from red to green, indicating that now the system is complete. And as you can see here now, my background check has passed. Okay, so now I can go back and process my sample as I wanted to demonstrate for you with this first sample. So I've loaded my samples onto the rack. I go to the run man. I place my rack with the arrows facing correctly. And then this is where I press start. Okay, so as soon as the instrument will then pull through the rack, and it will scan first the barcode of the rack to identify this rack itself, and it will then also scan to identify the samples. But because my samples that I have loaded now do not have any barcodes, this is where the system automatically will assign a sample ID for the samples that I'm processing. The samples now are going to be mixed, as we've heard on the presentation. There will be 20 inversions that will happen, and this happens for the first sample processing, and as the first sample has been pierced and processed, then the rack will continue to move. So it doesn't only mix the sample just once. Okay? And the throughput, as I have indicated, is 55 samples per hour, but it takes 1 minute to result a patient. Right, so as you can see, the LED on this power button is red, indicating that the instrument is now busy. And here at the bottom, we are able to see the dates and time, who has logged on, and also what is currently happening. So now what is happening now is that the sample is analyzing, and it has given an auto SID because my sample did not have any barcode. Okay, so as well, there is a cleaning cycle that takes place for only a few seconds in between sample. This is automated and cycle-based so that we're able to maintain that throughput of 55 samples. So while the instrument is running, you are able to load another rack of samples as the samples come through, and you don't necessarily need to go again and press the start button. So if the sample is processing, then you can just continuously be loading your sample and walking away. So this actually gives you a true walk-away capability. Okay, so we'll allow for this sample to finish, then we will do our next demonstration. Right? So now on the page, while I am on this sample analysis screen, I'm able to see there is only the last patient that has run. So as you can see here, it's already giving the sample that I was just running now. It has given it a specimen ID or sample ID. It is showing the cassette positions, the cassette number and the position that my sample was on, and also is giving the date and time that it was on. So if this was connected to LIS and the demographics is pulled through, we'll be able to see the patient's information there. On here, we can see the patient results very nicely. On this left-hand side is all the white cells and the white cell parameters that we see, the 5-part differential, and also we can see the scatter plot as we have indicated. So if you click on your scatter plot, as Gary has shown in the presentation, you are able to now enlarge the scatter plot. Okay. In the middle is the red cells with the hemoglobin and the red cell indices with the red cell histogram, and we are also able to enlarge it. On the right-hand side is the platelet with the platelet parameters and the platelet histogram, and we are also able to enlarge the platelets on here. Okay, so also the system will give us messagings to tell us if there's any flags on the instrument, and here we can see that the H&A check on the sample has failed, and we've got high MCHC. All right, so now for my second demonstration, I'll be showing you how do you run a sample in open mode. So I will go on to here. As you can see, there's a start and there's a single tube, okay? So I will press here on the single tube, okay? I will do next for me because I need to now identify my sample, okay? So if you are in a lab where there is a barcode on the sample, you just easily scan your sample and then that sample ID will show up here. But for this purpose of this demonstration, I will be putting 1, 2, 3. Okay. Acknowledge. Okay, save these changes. Okay, so now I want to run now a open tube. So I'm going to press on the open tube and it's giving me a warning to say that I've selected to run this open tube and I need to open the autoloader door. So this autoloader door, please, you as indicated here, you just need one finger at this pressure point and it automatically opens. Okay, so you don't need to pull the thing through. Okay, so now here, press OK to extend the probe. Okay, so when I press OK, as you can see, the probe extends. Then this is where I mix my sample. Good laboratory practice, guys. Okay, so I mix my sample, open it, immerse the sample, then press run. So it's giving me a warning to say I must ensure it remains, and you can see there, okay, when it's done, it retracts. And there I have run my sample in an open mode. Okay, so this is how easy it is. And as I have mentioned, the time to result will be 1 minute. And if you had to use the system open mode full time, then you will have a throughput of 60 samples per hour. Okay, any questions on the chat? Nothing? All right. Okay. All right, guys. Now my sample is finished on the open tube. So good practice will be that now that I'm done, I'm going to close the autoloader door. Okay, but now for the next demonstration that I want to do, I want us to now run a sample on the rack, and because I wanted to see inside the instrument, I'm going to open it, and because I'm on a service mode, I will be able to demonstrate this instrument open, but on normal day-to-day practice, you will not open the system. Okay, so I'll go on the running man again and make sure that your rack is facing the right direction. Start. Okay, so you see that the autoloader prepares to take the rack through. Okay, so let's watch how it mixes. So this is how it is now mixing our samples in here. 20 inversions, as I've mentioned. So on this, we are able to also run, the QCs are also run on the same way. So here's our 3 levels of QCs that you also run in the similar way. Okay, so also as mentioned, the instrument runs 17 microliters of blood, and as you can see, the sample is aspirated while it's upright, okay? And also what you need to note is that the instrument uses the same sample probe for when we are running the sample on the autoloader or when we are running the sample on the open valve mode. So this is how the instrument is operating internally. Okay, so I think that one of the other questions that you might have is, okay, so now my rack is running and I receive a stat sample, then what? What do I do? Okay, so you are able to stop the rack while it's running. You do not need to wait for the rack to complete all the 5 samples in progress for you to be able to process that very urgent sample. So for me to do this, I will press here on stop. Okay, it will tell me that I want to stop the cassette, then I press yes. Okay. All right, so if an analysis was busy running at that moment, it will just only finish that one sample. So it will not finish the whole 5 racks on the samples for you to do this. After that, then it will then finish that one sample in progress, then allow you to run that urgent sample, either be a pediatric sample that has come in or one of those stat samples. So as I've mentioned that the instrument comes with the type 1 cassettes, and this only cap pierceable tubes are able to be loaded, and pediatric tubes that are not cap pierceable will not be loaded onto these racks. Okay, so now it's finished running that one, and now it's going to ask me to run my patient. Then what I will do is I will press next. Then I will do the steps that I have previously shown on how to run an open mold sample. And once I have done, then this is where I will then proceed with the rack. Am I good on time? Okay, good. Okay, so next. Okay. So let me demonstrate again for you guys how you run a sample on open mode. Okay. Press open mode. Okay, the probe extracts again. Then you press, you merge, you can see there is aspirating, goes solid, it retracts, then now it's processing my sample. So what you will see here is that it's analyzing my sample that I've given a sample ID for, which is 1585, is now currently running. All right, so this is how you will be processing your samples on the DxH 560.
Thank you very much, Lebo. Great analyzer. I think it's small, it's mighty, it's easy to use. It gives us what we require in a fully operational lab to be totally efficient. Just a few questions online. Is the reagents entered manually, or do we scan a barcode when we load the reagents?
Yes. I've got an extra reagent here to show. Okay, so all the reagents come with the barcode. So you will use your barcode scanner to be able to set up your reagent onto the analyzer. Yes, so barcodes, all of them. So quick demonstration. I won't be changing it because, so what you will do is you will go on supplies, you will go on setup, and there it will say scan the 2D barcode. So this is where you barcode and you acknowledge that. Okay.
So how often should we do the shutdown procedure?
The shutdown is every 24 hours. There should be a shutdown that is done on the instrument. Yes, so that this is to ensure that, because when you do a shutdown, it's going to put in the cleaner into the system to ensure that we do not have protein buildups that are going to block the apertures. So for uptime, good uptime. We need to ensure that we do not miss on those shutdowns.
Another question from one of our end users is then, what's the average consumption rate of the cleaner?
Okay, so now currently the cleaner is using 42.5 milliliters of the cleaner for a shutdown, but we are working on reducing that consumption. This is just, the cleaner is only used when you are doing the cleans on the instrument, so it's not used for any analysis. So those shutdowns is what we use the cleaner for.
Our consumers is very much focused on how we handle our reagents. Another question on the reagents, excluding the daily shutdown, how many tests can I get out of my reagents?
Okay, so with the reagents for hematology, it will be a bit of a tricky one to accurately calculate the number of tests that you get per reagent container. Because we have laboratories that are running, this instrument will be suitable for low to mid volume laboratories running from 10 samples to to about 120 samples. So obviously a lab that is running fewer samples will get fewer tests out, and this is because the instrument uses the reagent, the diluent, and the cleaners for the startups and the shutdowns, and also that there is expiration on the onboard reagents. So the labs that will get higher tests out of the reagents will be the labs that are running high throughput. So 60 samples and up will get optimal tests out of their reagents.
But then am I correct to say if labs are interested in our system and they supply us with the correct volumes per day, that we have a calculator that can calculate the reagent consumptions? We even include waste, reruns, and also amend that calculation to the procedure that the lab is facing and using their protocols.
Yes, definitely. So that calculator will also take into account the number of days that the lab is operating, the type. So accuracy of the tests that you are running per day is very important for us to give you the correct and accurate consumptions and cost per tests.
Thank you very much, Lebu. Really a great demonstration. It's nice to see that we have this small, compact, mighty analyzer. We would like to share a video with you guys, so please just look at the link and we will share the video, and that will give us more information and also just enhance what we've learned throughout these sessions. Thank you. Wow,
Wow.
that was a
So
nice
how is
video.
that?
Focusing on our new product, the DxH 560, bringing you all the benefits for your medium to large segment laboratories.
Yes, definitely designed with the user in mind.
Definitely. Thank you very much. Rachel, I believe that you are online. You are joining us. We would really like to welcome Rachel Burnside. She's the Senior Manager for Hematology Product Management. Rachel, if you can just share with us your camera. Welcome to this launch. We are excited to have you
Good
with
morning,
us.
Rachel.
So please take us through your section and just tell me when to progress with the slides.
Thank you. Good morning, everybody. I'm so happy that you guys are getting the 560 launched. This is really going to be an exciting product for you all. I understand that the audience is not all Beckman customers, so welcome to everyone. We would love to have you as our customers. And in addition to sharing our exciting new 560 launch, I'm going to give you an overview of our flagship products, the DxH 900 and the DxH 690T. I understand many of you who are our customers may have some older instruments, and that this is going to be like moving from a Cadillac to a Porsche if you decide to get the DxH 900 or 690T. They're very good instruments to have. And I'm going to talk to you a little bit today about why it's really so important to have, looking towards the future in your laboratory and maximizing your workflow efficiency with instruments like the DxH 900 or 690T. Some of the data points that I'm going to show you are based on North American data, but being in the field of medical technology, there are many things that are universal. One of those is that this is a highly specialized field where a lot of people are getting older in the field and they are retiring, and they're not necessarily being replaced at the same rate, which is really another important point for why we need to do more with less. And lab techs are really being pressured to do that. So we can go to the next slide. So again, like I said, some of these data points are based in North America, but it just drives home the point that I just made. There's an estimate that a fifth of all medical technologists in the United States will be retiring within the next 5 years. And I think this is probably true from what I have seen globally, is that med techs are actually getting older just as a group of individuals. And they're, like I said, they're not coming into the field as fast as they're leaving the field. And part of that is just because their education may not be supported in ways that they have been in the past. In addition, once those senior technologists and really experienced technologists leave the lab, they're generally not replaced with other senior technologists, right? So once they finally get a new technologist in the lab, it's probably a new graduate or somebody not as experienced, and it takes a long time to get that technologist up to the speed of the same person who just left, right? So it's not an even playing field when somebody leaves and someone new comes in. And it takes a long time to bring those techs into the lab in the first place. So we can go to the next slide. And then, of course, once the tech is in the lab, they're not just doing one thing. They don't have time to just stand at an analyzer and operate the analyzer or deal with the samples. They've got a million different things, literally, that they need to be taking care of throughout the laboratory that will take them away from having to deal one-on-one with a specific sample on an analyzer. So you want to have an instrument that really can do a lot of things for you, that's reliable, so you don't have to worry about, and free up that tech time to go and do these other things that techs have to do in the laboratory. Next slide, please. Interestingly, and probably not surprising to anyone in this audience, is that the CBC is the #1 most ordered test in the core lab. And in addition to all of the things that techs have to do in the laboratory, they're not just covering hematology. Many techs cover many different medical specialties that may include hematology, coagulation, urinalysis. It may include other specialties even. So again, this is just driving home the point that a tech in the lab is a valuable resource that does not have time to deal with routine samples that have to go through hematology analyzer systems. In addition to that, laboratories are held to a standard for turnaround time, and the STAT CBC TAT is the most measured stat and the most measured metric in laboratories to tell laboratories if they're doing well or not. Again, there are many things, even with challenging samples in a hematology laboratory, that techs spend their time doing. So in a typical laboratory that runs about 300 samples a day, which is not a hugely busy lab, but it's still, you know, a fairly steady lab. If we consider that 5% of those samples are challenging and have to have something done with them, and that on average, those samples are dealt with, takes 5 minutes to deal with those particular samples. And an 8-hour shift, you're looking at almost a quarter of the tech's time, over a quarter of the tech's time being dealing with these challenging samples. So again, we really need to have instrumentation that can really help maximize that technologist's time to free them up to take care of the challenging samples and to take care of the other responsibilities that those technologists are responsible for. This one is really an interesting slide. I had not ever quite looked at it this way before this slide was made. But if we compare the Beckman Coulter hematology analyzers, the DxH 690 or the 900, with competitive instruments, first of all, the DxH 900 690T only uses 4 reagents. So regardless if you're running a CBC or CBC diff, we only use 4 reagents. So in a laboratory, whether you run 100 samples a day or 1,000 samples a day, we have a lot fewer reagent changes than the competition. This saves a lot of time and improves productivity of the laboratory overall. So even from 100 samples a day, you'll have 85 reagent changes a year, and it'll take you about 4 hours, a little bit over 4 hours. Even up to 1,000 samples a day, where you've got almost 500 reagent changes a year, it's still a lot less than the competition. And you're still only using 20 hours, half a week over the course of a year to change reagents. So it's a huge difference in productivity of the laboratory not to have to change so many reagents over time. Next slide, please. And you may think, well, that's fantastic, but my laboratory has concentrated diluent for that very reason. Okay, granted, even in the same sample size, so 100 samples a day up to 1,000 samples a day, we're still got the same number of reagents that have to be dealt with. So really diluent is the only one that is then not having to be changed as often. We're still saving time with the 900 and the 690T. We still are not having as many reagent changes, still not having the same amount of time spent in front of the analyzer over the course of a year. Again, improving the productivity of the laboratory and saving staff time. Next slide. So I want to think about, this typical situation that is not unusual, actually, sadly to say, where we have a laboratory where the third shift tech decides, I'm done. I'm going to go to another hospital even. So they give a 2-week notice. That lab director now has a level of discomfort because now they know they're going to have a gap to fill on third shift because that was a senior tech taking their talents elsewhere. that this lab director knows it's going to take a long time to hire a replacement. And then it's going to take a long time to train that replacement. So other people are going to have to pick up the slack for that individual over time, which puts pressure on them and puts pressure on the laboratory. On top of all of that, they're going to be audited next week. So what is this lab director thinking? What do they have to do to make that comfort level come back? Well, that's where these instruments come in, because again, as I've been alluding to this entire time, the instruments that you see here, from the 690T to the standalone DxH 900, all the way up to work cell with slide maker stainer, are really intended to be the workhorse of the laboratory and to maximize laboratory productivity and efficiency by carrying the weight of the medical technologists and helping them do their job more efficiently. The benefit of this line of instruments is that they share technology. So in a hub and spoke situation, for instance, where you have a core lab at a main hospital and then smaller satellite labs, you can have the 690T on the benchtop in the satellite laboratory and a 900 or work cell in the main laboratory, and they share technology. So you know you're going to have consistency of patient care if that patient starts out at a satellite facility and then gets transferred to the primary hospital. They both do 100 samples per hour, and the slide maker stainer can make about 140 slides per hour. Of course, once you scale up to a work cell, that throughput goes up for CBC analysis. We have a number of research use only parameters that a lot of our customers really do enjoy using. It helps them get more information about those samples that they're running through their laboratory. Even if that information is not reported to the physicians, they still are able to make very valuable interpretations of the cellular components of that sample. And then finally, all of these instruments are able to have the early sepsis indicator. So I'm not going to spend a lot of time on that. I do have a slide on that later, and we'll spend just a second on what that is. In 2020, I'm proud to announce that the DxH 690T won the New Product Innovation Award from the US marketing research firm Frost & Sullivan. This was actually a really great surprise. It literally came out of nowhere. And somebody sent me an email from Frost & Sullivan and said, "Congratulations, you've been nominated." I was like, "Oh, that's fantastic." And the next thing I knew, we had won. So this was really, you know, in a very challenging year that was 2020, this was really a bright spot for us. So in this lab director situation where she's lost a tech in the evening who is talented and has to replace this individual, this is really where the rubber meets the road, so to speak. And having instrumentation that allows you to have fewer manual interventions with routine samples is really going to help this lab director in the long run, because let's face it, techs leave, they do. So I actually used to be a tech a long time ago. And so I know that, you know, you run into these situations and you need to have the maximum productivity in your laboratory. So from the DxH standpoint, we have the high quality platelet technology that have more accurate and fewer flags that will help to really refine those samples that need to have a slide dropped, so you can understand, you know, what's going on with the sample. We also have automatic cell counting extensions for leukopenic samples. So this one's actually a really interesting technology. So once the instrument detects that there's not sufficient samples coming through the aperture and the flow cell that a regular sample would, it slows the counting down and makes sure that it gets all of the cells that it can over time. So that's really a nice feature and helps you get really accurate differential in those samples. In addition, for accuracy, we have triplicate counting. So every sample gets, every cell type gets counted 3 times just for that accuracy and sense of mind that you have got the right answer the first time. And then, of course, we also have automatic rerun and reflex of flag samples. And what's nice about this feature is that rerun mode is done at the same pace as the initial sample. So some of the competitive instruments on their rerun mode, they slow down, and it affects the overall throughput of the system. That is not true for DxH. We also have easy reagent management system. As I mentioned, we only have 4 reagents. Our diluent cube is 10 liters. They have a really cool little it's called quick disconnect. So you can change the reagent on the fly. It's just, you flip it off, and there's a magnet on the side of the drawer for the 900 so that the lead doesn't hit the floor and get dirty. It holds it in place for you while you're busy dealing with the boxes. And then you just flip it back on, click, boom, you're ready to go. So we've doubled it over the DxH 800. So those of you who have 800s, you will have twice the walk-away time with the 900 that you do for the 800. Okay, next slide, please. The set and forget features, right? So when you get this instrument, you can streamline right from the start, right at installation. So you can set your daily task. You can set reminders about QC tasks that you need to do. We've got this really nice integrated touch screen that if you forget how to do something, there are videos on the screen that will show you how to do it. The nice thing about those videos is they don't have sound, so you don't have to worry, if English is not your first language or whatever, it doesn't matter because they are universal without sound, and they're right there on the instrument. We also have intuitive software for easier communication and fewer touch points. So again, this integrated touch screen's got a lot of really nice things on it. You can load the lab's SOPs on it. You can load the instructions for use. There's a sticky note feature, so you don't have to have Post-it notes all around the frame of the analyzer. I think we've all seen that. You can actually have them right on the screen. And there's a stylus that you could actually write on the screen if you wanted to. I mentioned the videos. And we also have the 3D surface plots that you can look at the samples in more detail. And that is unique to Beckman Coulter. Really cool to mess around with the screen on a DxH 900 for sure. Also, I mentioned you can automate your QC and compliance tasks. So you just set it and you walk away. So you just, you can upload automatically to IQAP for peer group review, and everything you need is right there at a touch. I mentioned I was just going to have one slide about the early sepsis indicator, and which is remarkable for me, honestly, because one of my favorite topics to talk about for hematology. In 2019, we got FDA clearance for one of our parameters that is known as monocyte distribution width. What is monocyte distribution width? That is the dispersion of the size of the monocytes in that patient sample. And clinical studies have demonstrated that once the average of one standard deviation of the average of the size of the monocytes exceeds a certain level, then that patient's at an increased risk for sepsis. And we have a number of customers around the world who are using this clinically today to benefit patients. And one of the really nice things about this hematology parameter is that once it is activated on the instrument, it's automatically reported. So the laboratory doesn't have to do anything extra. It's just part of the CBC diff. And the clinicians don't have to do anything extra. They're just ordering. a CBC diff. There's no extra test code. There's no extra reimbursement that has to be billed for. It's simply an additional data point on the CBC diff. As I mentioned, when the MDW value is above a cutoff, then the patient's at an increased risk for sepsis. And if it's below that cutoff, then the patient is at a decreased risk for sepsis, even in the face of an infection, although it's not 100%, but it can give the physician some reassurance that this is not one of the most critically infected patients, and they may be able to focus their resources somewhere else on more critically ill patients there in the emergency room. It is the only hematology-based biomarker that has an FDA claim for sepsis, and this is exclusive to this DxH 690T and 900 technology. So this is a really great feature. And then I want to just finish up by showing you the footprint. So for those of you who have the predecessor instrument, the DxH 800, the analyzer itself is the same. A work cell system is actually a little bit smaller because, as you know, the cart with the laptop stand is no longer there. It's no longer needed because we've got the monitor integrated right on the analyzer. So this little black square that's standing around the DxH 900 in this mock-up booth demonstrates a 2S. So this would be 2 analyzers and a slide maker stainer. And then the gray dotted line is the next smallest competitive instrument work cell system. And then I don't know if you can appreciate, there's a white line that even goes out almost all the way to the edge of this mock-up booth. And that is another competitive analyzer system. So we really have, from a work cell perspective, the smallest system on the market. So as you all know, space is gold in a laboratory. And so this really helps those laboratories, again, time, efficiency, workflow, space, all the benefits of our flagship instruments to help the laboratories do the most they can with the fewest resources necessary. So this slide is really just showing you some high-level benefits of the DxH 900 690T over the legacy instrument, which would, as I mentioned, is a DxH 800, but they're maybe even older instruments. And then on the bottom, we're showing some improvements over our competition. So we've not just, made the 900 look nicer than the 800. They really are different instruments, and the 900 has taken all of the lessons that we've learned through time and put them into this instrument for reliability improvements, for user interface improvements. We've got a lot of great feedback from technologists who use this instrument that they just love it. So we're really proud of this family of instruments, and we hope that all of the instruments that you've seen today, including the 560 autoloader, can really help your laboratory maximize efficiency and improve productivity. And we would love to have you as our customers and keep you as our customers forever, because this is just a really great system to have. I think this is my last slide. It is. Thank you so much. I really appreciate the invitation and was so happy to participate in this event with you. Thank you so much.
Rachel, thank you very much. We really appreciate it. We know it's early for you in the US,
Yes.
but to be part of our South African or Southern Africa DxH 560 launch is really a privilege. Just you mentioned some of our customers online is currently our customers. We have also a lot of new customers or potential customers. As you say, we really want to grab that. When we look at the DxH 800, and there are a few of these systems in our South Africa installed base, can you please just highlight some of the most important features or differences between the DxH 900 slide maker stainer and the DxH 800?
Oh, there are so many differences. I wish I actually had this slide in the deck. We have a team in Miami here dedicated to reliability improvements on the slide maker stainer. And between the Slide Maker Stainer 1, which is what we call for the 800, and the Slide Maker Stainer 2 for the 900, just in 2019 alone, there were 40 reliability improvements put into that instrument. So one of our core values at Danaher, which is the parent company of Beckman Coulter, is continuous improvement. So we're never satisfied with what we've got sitting in front of us, right? Even if it's a great instrument, which these are, we're never satisfied. So the throughput is very similar. The reliability, much better for the SMS2 than it is for the SMS. Slide Maker Stainers are challenging instruments. They have a lot of moving parts, and they deal with particulate matter. So it does not matter the vendor of the Slide Maker Stainer. They are the most challenging instrumentation that any vendor has to deal with. But we're super happy about the quality of the SMS2, and I think you guys will be super happy with that as well.
Thank you very much. Yes, it's evident that we have an instrument within each and every segmentation within our total market. I think if we review the slides, and you haven't seen the first slides initially when we started, when we showed our whole total product diagnostic portfolio, it's evident that we can serve small labs, medium labs, large labs, and even our ultra-high labs. So thank you very much. If there's any other questions for Rachel as well online, please put it in the chat and we'll gladly answer that. So Rachel, really thank you very much. We appreciate it.
Thank you, Rachel.
So I would really like to thank our presenters, the Beckman Coulter team that made all of this possible today. I really want to thank Renee Snyman, our Managing Director for Southern Africa, for giving us the opportunity to host this launch. Thank you very much, Renee. I want to extend a warm thank you to Marius van Rooyen. He's the Managing Director of Eventcasts. Some of his crew, Stefan, Klaus, you really made it possible for us to have this virtual meeting today. To connect, even if we have challenges in South Africa at the moment. Load shedding is very evident for us. We are working through that. Sometimes we have connectivity issues. We are not trained actors.
Yes.
So yes, we are flexible and adaptable when we do these launches. I would also like to thank Mart-Marie Weideman from Tusa Reservations for her continued support with making all our marketing events a special place. And then most important, I want to thank you guys, our loyal customers, for your engagement, the questions online. We really appreciate your valuable time. We hope that you are as excited as us, because we are excited about this small and mighty DxH 560 instrument, and it will be a perfect fit for your laboratory. Before I say thank you, stay safe, and enjoy the rest of the day, I would really just like to emphasize what we lost this morning with the video, and we will share it again, that you are in charge of your own destiny, with your own success in your own laboratory, when it's personal, even in your own lives. So when you look at this video, see how you can take this content, this powerful message, that you are in charge of your own course. So help us to help you to keep on this course and chart it for 2021. Thank you very much.
Thank you all for joining us today. Stay safe.
Our journey started with a spark, which fueled the fire, igniting winning and creating meaningful momentum. We've accelerated and fought to overcome obstacles, and together we've experienced breakthrough moments and exciting achievements that propelled us to next level winning. Now is our time to define who we are. While others look left or right, we embrace this journey with purpose. Focused, determined, brave. We don't cut corners. We don't take the easy way out. Together we work harder and fight smarter. Our path is strategic. Our plan is strong. As we master our tools, we will execute flawlessly to chart our course, moving forward as one team towards one goal. The future is wide with many unknowns, but what we do know is we are ready. Arm in arm, standing tall, relentless and courageous, prepared with powerful tools and unified with a singular mission, charting the course and conquering together, knowing the best is yet to come.